Okay, example 28. A weir carries a flow rate of 600 liters per second. If the head is measured with an error of 2%, calculate the percentage error using differentials in the calculated discharge. Also calculate the percentage error algebraically if the measuring device is too short. Now, remember from calculus, differentials is an approximate way, and the accurate way is using the algebraic way, but the two will be close to each other if the error is small. Just like 2%, that's considerably small. So first, a rectangular suppressed weir is used with length 1 meter and Francis formula, using Francis formula. And second, a Cipolleti weir is used. So by differentials, the formula for Q using rectangular suppressed weir and Francis formula is 1.84 length of grass head to that 3 halves. Since it is only the head that is erroneous, and we can combine 1.84 and L and treat it as a constant. So in general, the discharge formula is K head to the 3 halves. So the differential of Q is 3 halves of K, H to the 1 half times differential of H. So percentage error in Q is 100% times dQ over Q. Substitute. Percent error in Q is 100% times quantity 3 halves or 1.5 of K H to the 1 half dH over Q, which is K H to the 3 halves. So 100% times 1.5 is 150%. We can cancel K. We can cancel H to the 1 half. So what is left here is dH over H. And dH over H is 0.02. The relative error in the head. So it is 150% times dH over H, or 150% of 0.02. So percent error in Q is 3%. Then algebraically, since this is the formula and the measuring device is too short, so we have to add the error. So the final discharge with head adjusted is, we just replace H by 1.02 of H minus the original discharge, which is K H to the 3 halves divided by original discharge. So Q is K H to the 3 halves. So delta Q is K final. So K times the head should be 1.02 or 2% greater than the head, raised to 3 halves minus H to the 3 halves minus K H to the 3 halves, which is the original Q. So percent error in Q is 100% of delta Q over Q, or 100% of K, factor out K H to the 3 halves here, so we have 1.02 quantity 1.02 to the 3 halves minus 1 over Q, which is K H to the 3 halves. So we can cancel this. So 100% of quantity 1.02 to the 3 halves minus 1 is 3.015%. So notice that this is the accurate way, and it is very close to the result using the approximate way. Then by using Cipolleti weir, 1.859 LH to the 3 halves. So since 1.859 and L are constants, we can combine and write it as K H to the 3 halves. Since the formula is the same as that of the rectangular suppressed weir, so the percent error in Q by differentials would be the same. So we will not go over with this differentiation because it's the same. Same is true with the algebraic way because the formula is the same. So that's it for this problem.